All right, it is 5 o'clock, so I think we're going to get started. Thank you all for sticking around to the bitter end here. I'll let a couple more people file in. My name is Scott Sanderson. This talk is Designing for Interaction. And yeah, thanks for coming out. So kind of the thing that prompted me to want to give this talk was actually seeing another talk by Brian Cantrell, who's the CEO or the CTO at Joyent, which is a sort of cloud company. And they're sort of most famous as the people who originally developed Node.js and then later having a somewhat sort of acrimonious breakup with Node.js. And in 2017, Brian gave a talk kind of about how that came to pass. And essentially the thesis of his talk was that what they realized was that the Node.js community had different values for what they cared about in their software, and that over time, Joyent and the Node community had sort of drifted apart in what they, or actually really they had never been aligned, and they eventually realized that they had different values. So that's sort of the leading context. So one of the things that Brian says early in that talk, he says, values are what's important to you. And we all believe that we have the same things that are important to us because they're important to us. So of course they're important to you. But that's not the case. We always talk about the right tool for the job, but when it comes to choosing a software platform, it's not really the right tool for the job, it's the right values for the job. And so in the context of this talk, he's talking about this idea that the kinds of tools and the things that they cared about at Joyent turned out to be not the values of Node, and so they ended up kind of drifting apart. And so what I want to think about is that how does that apply to Python? So obviously he's talking about language choices. We tend to think that within a language we kind of have a single coherent set of values, but I'm going to make the claim that even that's not true. And I think it's sort of uniquely not true in an interesting way in Python. So kind of the thesis of this talk is that Python library design has some kind of unique challenges because code is used by different communities with divergent technical values. And that's not a bad thing. It's not like there's a group that's wrong and a group that's right. I want to argue that that value divergence is a natural product of the different modes of interaction that different users have with code that's written in Python. So that's sort of the sub-thesis. And then the sub-thesis is data science and traditional engineering teams often struggle to collaborate because of this divergence. So the fact that data science teams and traditional engineering teams work with Python code in different ways is, I think, at the root of a lot of the struggles that those teams often have to collaborate or to, say, move models from design to deployment. So what are the goals for this talk? One is I want to sort of talk about in an explicit way how interactive and non-interactive development can cultivate these different software values. I want to help us try to identify design decisions we're making where I think in a lot of cases we implicitly make decisions that are geared towards one set of values or another set of values that are usually rooted in the kinds of work that we do sort of day to day as developers. And I want to help us sort of identify and make those decisions a little bit more consciously and a little bit more explicitly. And then finally, I want to try to conclude with some advice for structuring code in a way that affords both interactive and non-interactive use. A little bit about me to sort of give context for why you might want to listen to what I have to say about any of this. So I'm a principal engineer at Quantopian. Quantopian is an online platform for developing financial analyses and quantitative trading strategies. So we have a big hosted online platform where we have a whole bunch of financial data. People can come and work interactively in Jupyter notebooks to analyze that data, as well as design trading strategies, live trade them, enter them in contests, and ultimately our business model is trying to fund well-written algorithms and offer those users capital allocations. So we have both sort of an interactive Jupyter environment as well as a whole host of sort of more, I don't know if I want to say traditional, but sort of large non-interactive applications built for working in this same domain. And so in particular, my responsibility is sort of leading the team that's responsible for both the backtesting APIs as well as the Jupyter-based research APIs. And what that means is sort of day to day, my work is mostly either API design or what I would call like data infrastructure. So sort of figuring out how we're going to get data from wherever it is to a user's terminal or a user's Jupyter notebook or a user's backtest in a way that's performant and coherent and sort of makes sense of the messy world of financial data. So the code that I commit, that I'm writing and sort of pushing and code reviewing is sort of traditional application code. But I actually do a lot of exploratory analysis because we make this big hosted Jupyter notebook platform. And also, as we're integrating new data sets or bringing new data onto the platform, there's a lot of sort of exploratory analysis to understand whether that data is correct, what that data means, whether there's weird anomalies with the data. So I kind of have a little bit of a foot in both camps in terms of the traditional application development as well as the interactive development. So that's kind of the context for the talk. So backing out to kind of the 10,000-foot view, what is it that makes a piece of software well designed? I think anyone who asks you, or who asks a question like this that's sort of this open-ended and tries to give you a direct answer is lying or is wrong. So the only answer I can really give to that is it depends, right? So well, you might ask, well, okay, on what? Like, what does it depend on? And then sort of mumble context. But let's dig in a little bit more into what context means in the context of software design. So one thing that context might mean is language features and language design. So a design that's good in one programming language might not be a good design in another language. So things like the type system, the object model, the runtime, whether you have garbage collection, what your concurrency model is, whether you have a compiler, all these things can make a design sort of useful and natural and ergonomic in one language and not so in another language or vice versa. Another thing that affects whether a design is sort of a good design is the ecosystem of packages that exists in that language. So that includes things like the standard library, which in Python we're sort of fortunate of having. By the way, most of what I'm going to talk about today is Python, but much of what I'm going to talk about does apply to other languages, but I do think Python kind of has some unique and interesting challenges. But anyway, so things like the standard library, as well as third-party packages. So if you're, say, working in the numerical Python ecosystem, it's probably important for you that your library integrates well with packages like NumPy and Pandas and maybe SciPy or scikit-learn. So the fact that there's other libraries and other code that your code's going to interact with should influence how you design your code. Another thing that influences whether code is well designed is how it can interact with other tools. So things like compilers and linters and test frameworks and packaging tools. One of the things that we should be considering as we're designing our software is how well can the code written in the way that we're writing it be improved or be made easier to work with through these kinds of tools. Some kinds of tools or some kinds of designs are more amenable to, say, static analysis or to linting or to compilation or other things like that. And then another thing is just sort of documentation standards. How is someone going to learn about your library might affect how you're going to structure your library. And I think these are the kinds of things that Brian Cantrell was talking about in his talk, where he's talking about Node.js and the kinds of things that affect at the language level the community and the values and what things become a reflection of the values of that community. One thing that I think is unique about Python is that we also have these different modes of use. And I think Python's somewhat unique in that we have such a diversity of modes of use for the language. So there's folks who write sort of traditional standalone servers in Python. There's command line applications. There's people whose primary interface with the language is REPLs, and then there's also a large and growing community of people whose primary interface with the language is Jupyter Notebooks. And one of the things that I want to point out here is that there are a fair amount of languages like R or MATLAB or Julia where people do interactive development and their primary interface to the language is interactive development. And there's lots of languages like C or C++ or C# or Java where people's primary interface to the language is sort of standalone application development. I think Python's somewhat unique in it being the case that there's large communities that do both of those kinds of activities in the language. And I think that sort of imposes some unique challenges on the language. So you can think about this as kind of being on this sort of spectrum of interaction. You can see my very fancy diagram here of ASCII text. So all the way on the interactive side, you're just writing in a REPL where you're purely just working in this ephemeral session. All the way on the right, you might have something like a system daemon, which is running persistently in the background forever and you don't even interact with as an end user. Somewhere in the middle, you might have something like a web service where the server is running somewhere, but at least you can interact with the program sort of indirectly by it feeds you a UI or you can make requests to it or something like that. And then sort of further on the REPL spectrum is something like the Jupyter Notebook, where the workflow is an awful lot like what you're doing in a REPL, but you have kind of a persistent, long-standing document that's a record of the work that you've done. And so Python kind of spans this whole spectrum of the different kinds of work that people do with the language, and that affects the way that they think about and work in the language. So I want to point out some particular features that I notice, at least when I'm doing interactive development, and then contrast them to the kinds of things that I notice when I'm doing non-interactive development. So when I'm doing interactive development, Most often I find that the things that I'm doing are independent of code that I've written previously. If I'm loading up a Jupyter notebook or I'm loading up a REPL, I'm not necessarily building on a large corpus of code that existed previously. I'm taking the new data that just showed up today and pulling it in and trying to understand what's wrong with it. Or I'm trying to understand like the logs coming out of my machine, but it's sort of independent little units of code, and they're not necessarily part of a long, persistent, large code base. Another, I think, sort of distinctive feature of interactive development is that the author, the end user, and the operator of code that's written interactively are often all the same person. So, obviously I'm the one writing the code when I'm doing interactive work. I'm also the one who's going to consume the outputs of my code most of the time. And I'm also the only one sort of operating or having to work with the code that I'm writing there. And that's going to be in contrast to some of the other things I'm going to talk about. Another, I think, really important thing is that when you're doing interactive work, your results are directly visible to you, right? So you run a piece of code, you do pd dot, group by dot whatever, indexing with something, and you immediately get to see the result. And if it's something you didn't expect, you can immediately look at that and see and try to understand, more directly, well, what went wrong in that computation. But you have this immediate feedback loop of here's what I did, here's what I got, was it what I expected, and then you can proceed from there. Sort of going along with the author and the end user and the operator all being the same. Even in the case of notebooks, you don't, because we still have things like notebooks, you can have more than one author, but in my experience, you usually have relatively few authors. You might have a couple people working on a notebook, but you tend not to have, a 30-person engineering team working on a notebook. And finally, I think one of the key distinctive features of interactive development is that you often don't know what it is that you're building when you're doing interactive work. And one of the advantages of interactive work is because of things like the direct feedback that you get, it's really useful mode of development when you're trying to explore what it is that you're trying to do to begin with before you actually go and do sort of more traditional development. So I want to contrast some of the things that I just said with application development. So whereas in interactive work, we're mostly sort of creating new work from full cloth, most application development, in my experience, is modifying an existing code base. Right? You have some long-running server project or some long-running library, and you're adding new things to that, or you're changing things in that, or you're fixing bugs in that, but you're making changes within the context of an existing code base. Going along with that, the author and the end user and the operator are usually not the same person for a traditional application. One person's going to write the code. Another person's going to be the person actually interacting with that code when it's running in the wild. So if I write a web server, for example, it's usually so that someone else can see the web pages served by that server. And finally, usually a third person is the person who's actually going to deploy that server into production and is going to monitor it and yell at me at 2 a.m. if it breaks, or watch the logs and gather metrics and do all the things that actually have to happen to make sure that a server continues to run in production. Another feature of application development is that our results, or our sort of intermediate results as the application is running, are not directly visible to us in the way that they are in a REPL. So, we can log things in our application, but then someone has to actually go look at the logs. There's not a person sort of sitting there constantly I hope at least, there's no one sitting there constantly tailing the logs of your servers to see, what the intermediate value of X was in every single function in your application. We also, as part of the idea of modifying existing work, we usually have many authors for a standalone application, and that changes some of the things that we care about. And finally, we generally know ahead of time what it is that we're building. If we're at the point where we want to create a standalone traditional application, we usually know more or less what it is that we're building. And so because of these features that I talked about, I'm going to claim that we have different software values when we're developing these different kinds of applications or these different kinds of code. So what are the things that I care about when I'm building an application? So probably first and foremost, the things that I care about is maintainability of that application. And by that, what I mean is essentially how easily can I change the application and be confident that that change is correct? And sort of the corollary of that is how confident am I that someone else can also come along and change that application, and I can be confident that their change is correct. Another important thing that goes along with maintainability is testability. So how easily can I test individual components of my application in isolation? Can I run the application without access to production systems? Can I do it without access to the internet even? That's a really nice feature to have for an application that you're trying to test in a comprehensive way. And finally, sort of how long does it take to do all of that can be very important. Again, sort of these values aren't totally orthogonal in a lot of cases, but they build on one another and they reinforce one another. So another piece of this is modularity. So how easily can I replace different components of the application? Can I swap out my database for a different database? Or can I swap out my logging engine for another logging engine, something like that? And how easy can I reuse components of my application in the context of another application or in another part of the application? Robustness, how well does my application handle errors or unexpected errors? Or even how well does the application detect that there were unexpected errors or unexpected inputs? And that's a little bit of a different virtue than handling unexpected errors, is realizing that there's unexpected input in the first place. And this can have implications for things like security, where one form of unexpected or erroneous inputs are explicitly malicious inputs. And finally, operability. How easy is it to deploy or upgrade my application? How easy can a non-expert see that something has gone wrong with my application who didn't work on that application and realize that something's gone wrong and recover from failures? And one more thing is performance. And performance isn't necessarily solely the purview, I think, of applications as distinguished from interactive use, but I think we care about performance in different ways for interactive use versus application development, where if I have something that takes 150 milliseconds interactively, that's basically free for me. But if I'm doing something that takes 150 milliseconds 10,000 times in a loop in my application, now I care about that quite a lot. So the ways that we care about performance can often change between different kinds of applications. So again, to contrast that, what are the things that I care about when I'm working interactively? So I think sort of the thing that I care about most is, it's kind of a silly thing, but it's actually like, how easy is it for me to physically type the things that I want to do? Like, can I get the ideas out of my brain and onto the page, as quickly as possible and with as little friction as possible? And part of that is just, is the API super verbose? Does it require me to think about things in a way I don't want to? But another feature of this that I think is often overlooked is things like, how well does the library work with tools like autocompleters? Because is the library amenable to being aided by whatever tools I can bring to my disposal? And I think this is one of the reasons why people who are static typing advocates, for example, one of the benefits that they'll tout from that is that statically typed languages can be aided by tools in this way. Another interesting feature that I think I tend to care about more for interactive work versus application development is discoverability. So if I'm learning a new library or if I'm trying to do something in a new library interactively, how easily can I find the things that I need? And how easily can I learn to use those things? So there's one thing just sort of to get a listing of all the functions or all the classes available in a library, but then also can I, from just working with the application, or working with the library, can I get documentation, or can the API design teach me how to use the language or how to use the library just in virtue of, say, the names of the functions or the names of classes or what it does? And can I do all those things without disrupting my train of thought? So obviously we can always have externally hosted documentation, but especially for interactive work, if I can learn these things, if the tool can teach itself to me without me having to break my train of thought and go somewhere else, that can be really valuable. Another thing that I care about when I'm working interactively is flexibility. So usually when I'm doing interactive work, I'm doing sort of a new but slightly different thing every time. And so a thing that's valuable to me is to be able to tweak and reuse the tool in different ways. Things like, I'm loading a file that has a different delimiter, or I want to be able to move around where things are on disk. In general, because when I'm doing interactive work, I don't know what it is that I'm doing ahead of time, it's important for the tool to be able to adapt to whatever needs that I have. Kind of going along with ergonomics is this notion of intuitiveness. So does the library's model of its domain match my mental model? And again, this is useful everywhere. All of these things that I'm going to talk about, both for application development and interactive development, are important across both contexts, but I think they're more or less important in different contexts, depending on what it is that we're doing. So if a library has kind of a weird way of modeling its domain, when I'm doing interactive development, I'm usually not working with that library all that often, and it's not that big of a deal, or I can sort of stash it behind a helper function and I don't have to think about it anymore. If I'm working with the library regularly interactively, I have to be sort of constantly interacting with this thing that doesn't match my mental model. So I think that becomes more important to me when I'm doing interactive development. So kind of to summarize the contrast there, when I'm working on an application, I find that I'm mostly concerned with minimizing the long-term costs of maintaining and operating the application. And in contrast to that, when I'm working interactively, I'm mostly concerned with essentially getting ideas out of my brain as quickly as possible and with as little friction as possible. And those aren't by themselves inherently in tension, but what I want to claim is that often in practice, when we're making design decisions in our code, we're forced to make choices about which of these values we're going to prioritize in a given decision. Right, so when it's often the case that design decisions force us to choose between these conflicting values. Sorry. And I think we tend to make these decisions sort of implicitly or automatically without thinking through them carefully. And so I want to, and this can make it harder for us to understand why people disagree with us. If someone doesn't like the way we wrote an application, it's easy to just say, oh, that person's wrong, right? Or that person doesn't understand what they're doing, or that person's a bad programmer, or a bad engineer. And I think more often it's the case that when we disagree with one another, it's usually because we disagree over what's important or what's valuable about the software that we're writing. So I want to talk through a couple cases where I think trade-offs or design decisions that we make in our software can sort of benefit or detract from some of the different values that I just talked about. So one example that I think comes up a lot is optional arguments. So optional arguments in Python allow you to ignore rarely needed parameters, right? I can have a function with a bunch of arguments or a class with a bunch of arguments, and I can make it so that people don't need to pass those arguments unless they want to change something about the function. So this is a win for ergonomics, right? I don't always have to pass this argument, so it's less typing for me. And it's also a win for flexibility. It makes it easy for me to write a function with lots of options and without sort of paying the ergonomic burden of someone having to pass lots of options to my function. On the other hand, this is a loss for a lot of the things that I think we care about in application development. So it can be a loss for robustness in that if we have a function with many default arguments, but some of those arguments are really important to get right, then by having lots of defaults, we can mask errors where when we refactor a piece of code and we forget to pass an argument, if that argument were required, then that would become a hard error and it would probably cause our test suite to fail. But if we have a default, then we can often sort of silently continue on and either fail in a more confusing way later, or even worse, sort of get all the way to production before we realize something's gone wrong. It can also be a loss for testability. So if we have these big functions with lots of default arguments, it's very hard for us to test all possible configurations of those functions. And so it can be very hard for us to be sort of confident that all of the all the behaviors that we care about are correct. It can be a loss for maintainability because often when we have defaults for some function, we have sort of families of related functions that should share the same defaults. And if we update one of those defaults, we have to remember to go update all those different places. And there's ways we can structure our code to get around that, but it can be an extra mental tax on how we have to think about and maintain that code. And one more point I want to make about optional arguments is that having lots of optional arguments can often obscure what the expected production code path is for a piece of code, where actually in production, mostly, or always, we're going to run something in a particular way. But for interactive usage or for sort of standalone other contexts, we can run this with overridden defaults. And so having all these defaults can actually make it hard for us to know how do we expect this to be called in particular contexts or in particular ways. Another example of a case where I think we often make trade-offs between interactive usage and application development is with globally visible configuration. So what I mean by that is configuration that essentially any part of your code base can access without having to be passed it explicitly as a parameter. And this is sort of the inverse in some sort of the dual of optional parameters, and that this allows us to, whereas optional parameters allowed us to avoid passing things that we didn't usually want to pass, global configuration that's available everywhere allows us to not pass things that we always want to pass. And that's useful as long as we really do always want to pass those things. And that, in my experience, turns out to be actually very rarely true, at least in application development. So again, this is a win for ergonomics, right? If I've got some big pile of data that needs to connect to 3 different databases and 2 file systems and needs permissions and all these other things, then if that's all in a config file that's just magically available to me, then I don't have to type all that stuff out in my notebook or in my REPL session. But again, it can be a loss for maintainability. So it makes it harder for us to know what parts of our code base depend on what external resources. It can be a loss for testability because if functions all over our code base are depending on sort of globally available configuration, then if we want to test in isolation without talking to real production systems, then we have to monkey patch those things, or we have to have different versions of them. It makes it harder for us to test things and be confident that our system works without talking to the real production system. And it can be a loss for modularity because it means that if I have a unit of code that depends on global configuration, then I can't use that code unless I have that global configuration available. So it's harder for me to move that piece of code to another part of my application or to a different application that doesn't provide the same set of global configuration. So I have an example of this that's actually taken from an internal project at Quantopian. And can people read that okay? Is that a reasonable file size? All right. So on the left, I have a version of a function called getAlgo that was originally written in a notebook. And essentially what this is doing is trying to load some results from an algorithm backtest. So it's an algorithm that's run, it's simulated placing a bunch of orders, and then it's going to fetch the performance metrics of that algorithm. And we can see that this is like pulling things from a whole bunch of different external databases. So we've got like a metadata database and a results database. We've got a Cassandra database for something else. You can tell the system's kind of grown organically over time. We've got this thing called the data portal that provides an interface to all of our pricing data. And this function that was sort of extracted out of a notebook was originally designed to be called both interactively and from sort of a long-running batch processing job. And we can see that because of that, it's got all these default arguments where you don't have to pass all the different database connections to it. And if you don't pass them, then it'll go import a configuration object and make a new database connection, and then it'll use that for the context of the run. And that's really useful when you're using this interactively in a notebook, where I just want to say, here's the ID, please fetch these results for me, and let me analyze this backtest. But it can make it really hard to test this function reliably, because if I ever accidentally forget to pass one of these arguments, this thing's going to immediately grab the configuration, often from my local developer credentials, which means I can accidentally end up running against an externally shared system, which fortunately this is read-only in this case, so the worst case scenario there isn't too bad. But you hear horror stories every now and then where someone runs their test suite against a production system or a staging system, and then their test suite teardown runs and they drop the database. So you want to, if you're paranoid about these things, and you should be paranoid about these things, you want to make it really hard to accidentally run your test suite against production systems. And one of the best ways you can do that is make your test suite totally independent of whatever sort of developer level configuration you have. And so anyway, so this is a system that was developed interactively and prototyped, and then eventually it got sort of moved into a more robust production setting. And on the right, you can see what ended up happening to this function. So the first thing you'll notice is it's got no default arguments anymore. And the second thing you notice is that the actual direct database connections have been sort of abstracted behind these like reader objects. So now we don't just work directly with a database. We've got like a metadata reader and a backtest results reader, and those can be swapped out with real database connections or sort of mock and memory versions of them. And they allow us to write programs against these interfaces without having to sort of have direct connections to the databases. And so I think this is sort of a useful example of cases where designs that were useful and helpful and productive for initial interactive development sort of were a liability when we had to take them into production, and so we ended up having to make substantial changes to the code. So that's one example. Another case where I think we often find ourselves running into challenges that are, or running into tricky design questions because of the tension between interactive and non-interactive code is what should we do when there's an ambiguous input to one of our functions? And the Zen of Python is sort of this little Zen cone that comes with the language, and one of the lines in the Zen of Python is, in the face of ambiguity, reviews the temptation to guess. And I sort of particularly like the phrase of the temptation to guess here, because it feels like you're doing a good thing for your user, where it's like, I knew what you meant when you passed me a string instead of an integer, and so I'm just going to call int on the string before I do whatever else I did with it. And so I think, I'm not totally sure why this is the case, but I think it's often the case that the temptation to guess becomes really strong for code that's used interactively. I think it's because as a user, you're looking at a piece of code and you see, get index of the string 2014, and you're like, you knew what I meant there because you're looking at it right there. And you're not thinking about how in the context of a larger system that can accidentally sort of mask errors or cause unexpected outputs to happen. So from an interactive user's perspective, it sort of feels pedantic for a piece of code to throw an error on an unexpected input that seems like it has sort of an obvious interpretation. And so sort of every user's like, come on, you know what I mean here when I passed you, the string instead of the integer. But we see libraries all over the place, who have, in the name of convenience, given in to the temptation to guess, say. So an example that I work with quite a lot is Pandas. So, and by the way, in all these examples, I'll talk about this later, actually. I want to say I'm not denigrating Pandas or trying to dunk on Pandas. I use Pandas enough that I've gotten angry at it, and that means it's solved real problems for me. But anyway, so as an example of this, Pandas has a data frame class, and if I have a data frame here, and I can have a datetime index. And usually the way that you get values out of a datetime index is you do like df.loc of pd.timestamp 2014 01 02. And that says, give me the values associated with the row with that index. And that's great, and that's super useful. But it also has this sort of interesting behavior that I can do, just look up with a string, right? So I can do 2014 01 02, and I'll get that same result. So I didn't have to give it a timestamp. I can give it a string, and it says, oh, okay, that probably means what you wanted was the timestamp of that string. That's not too bad. Like, I don't feel too bad about it doing that, and it's super convenient in the REPL when you've got a data frame, and it's annoying to have to type out pd.timestamp of all this thing all over the place. But it gets even more convenient, actually. So I can do pd.timestamp 2014 01, and that says, give me all the things for just the month of January. Which again, if that's what you meant and that's what you wanted it to do, this is super convenient and super useful. And you can even go all the way back to 2014, just the year, and that says, give me all the values from this year. So when you're working interactively, and this is what you meant, this is super convenient. I have personally been bitten by this behavior at least twice, where I transposed 2 arguments in a function somewhere, and I had a string, and I had a timestamp, and I passed the wrong one, and then I got the wrong behavior, and then I got a cryptic error message. And it took me 15, 20 minutes to debug that or whatever, but I was briefly very confused about that. Another example that's I think more pernicious here actually is the behavior that Pandas has around coercions of different D types. So for example, if I've got a data frame here, and I've got a data frame with some integer columns in it, right? So the data, I've just got x and x squared from 0 to 10, or 0 to 9, and I've got 2 int64 arrays. And if you know kind of what Pandas' internal data model is, you know that these basically boil down to sort of C-level 64-bit integers just laid out in memory right next to each other. And one of the things that Pandas and NumPy that it's built on top of are trying to do is enable really efficient, high-performance computation with this kind of stuff. And so that's all great, that's all well and good. So now what I'm going to do is assign a value into a location in this array. And so I've got, for demonstration purposes here, I've got 10 values in this data frame, but this could easily be 10,000 or 10 million rows. And now what I'm going to do is just assign a new integer into this array, except I'm not going to assign an integer, I'm going to assign a float. And so now if I assign 5.0 to this location in the data frame, then what I'm going to find is that the entire column has been coerced to float from int. And so what that means in particular is that I've actually just now made a copy of all of the data that I had there. And so if this was a huge data frame and I was doing this repeatedly, this could become a really big performance bottleneck for me, where what I meant to do was load this big data frame and then edit a single cell, and I accidentally just copied half of the data that I had here. And again, this is a real bug that I've been bit by, both from a performance perspective as well as from a correctness perspective, where I assigned none in and got a nan when really actually that should have been an error from somewhere else in my program. And so probably about once a month I send this GIF to somebody in Slack. And again, I want to emphasize here that I'm not like, I send this GIF out of love, and because I've used Pandas so much and gotten so much value out of it that I've built enough systems on it that I get angry at it every now and then. But I think it's a useful reflection of this feeling of it was trying to be helpful, it was trying to do something for me, but really I just want it to tell me like, no, like please put an integer in there if that's what you meant, or have some way of saying it's okay for you to coerce here. And so to bring back to this kind of wins and losses, so handling ambiguous inputs like this can be a really big win for ergonomics, right? Interpreting strings as timestamps or interpreting floats as integers is really great when you're just sort of working in a REPL or you're working interactively and you just want to grab a slice of your data frame. And it can be a win for intuitiveness, where especially if you're not sort of super well versed in like the machine level representations of integers and floats, you might not immediately know why 5.0 versus 5 getting assigned into that data frame, one of those is throwing an error and the other one isn't. On the other hand, this can be a loss for robustness, right? It can hide bugs by causing the library to accept inputs that we never really wanted it to accept. It can be a loss for performance in some cases, where something that should have been an error condition actually gets accepted, but has some significant runtime cost. And this is both for things like the implicit array coercions, but it also can be the case that it can harm micro performance, because the library has to often do a bunch of work to figure out what we meant. And so there's cases where we'd rather not pay that performance overhead. And finally, I think this can be a loss for operability, where at some point, a lot of those examples I mentioned, we're going to crash later down the road, but now instead of crashing at the point where I made the mistake, they crash somewhere else, with a strange error about like having an unexpected D type or having an array that was much longer than I expected. And I've got just sort of some other smaller examples. So one example that comes up for me a decent amount is flat versus nested API services. So as an interactive user, it's really useful for me for a library to export most of the functionality that provides sort of in its top level namespace. So I can do import pandas as PD and then do pd.tab and see the plethora of options that PD provides for me. But one cost of that's I think a little bit subtle is that means that if I import pandas, it has to import everything else that pandas has. And so if you're doing things like command line applications, that can slow down your load times. And this affects us in Zipline, which is the open source backtesting tool, where we have this big backtesting tool, and we've got a bunch of entry points. And some of them run sort of big financial simulations where it's not a big deal to have a second of lag. But I've also got ones that just like log a little bit of data. And so you either have to have like lazy imports, or you have to do all these weird workarounds to avoid importing packages that are doing this. Another case that I see a lot in notebooks is sort of automatic or unbounded caching, where you're pulling a lot of results out of a database, and you're calling the same function, and you don't really want to have to think about like whether or not you've already loaded it. You're doing some interactive analysis, and so you throw like functools.lru cache on top of a function somewhere. And if you're just working with an ephemeral notebook, that's fine, because your memory use is going to grow and grow and grow, and maybe every now and then you notice and you hit restart all or whatever, and it's fine. But then if you take that code and put it in an application, now you've got a big memory leak. So these are just sort of other examples of cases where in the name of ergonomics or in the name of easier interactive development, I think we often make our lives harder in application development. So I want to sort of make it clear that I'm not trying to argue that like Pandas is bad or Pandas is wrong, or these other language choices are making the incorrect choice. I think, like, honestly, in the datetime case, I think in the balance of values, what Pandas' behavior there is probably right. Because even though when I run into that bug in my local development environment and I have to spend half an hour figuring out that I transposed two arguments, the amount of value I've gotten from just being able to quickly type something out in the command line, I think on the balance actually makes it worth it there. So it's not that necessarily one of these things is better or worse, but that for different users in different contexts, we have to sometimes choose to prioritize these values in different ways. And again, these differences in values are driven primarily by differences in modes of work, where depending on the kind of work that I'm doing, I care about different virtues of a library differently. So ergonomics matters more when we're starting from scratch. Robustness and operability matter a lot less when our results are immediately visible to us. So in the data frame case where we're indexing with 2014, when I'm working interactively and I see the data frame and that didn't do what I expected, I know I can sort of see that immediately and I can respond to that. Whereas if that happens in the bowels of my application somewhere, I don't necessarily get that immediate feedback if something's gone wrong. And going along with the theme of we don't necessarily know what we're building yet in interactive development, testability is only really useful if you know what it is that you should be testing. So what do we do with kind of these observations? So one thing I do think is true is that most interactively developed software either stops being used, and honestly that's probably the majority of interactively developed software, and most stuff is a REPL session somewhere or a quick notebook that gets sketched out and then thrown away. So most software either stops being used, in which case we don't really care about the maintenance costs of some of these changes that we've made, or it gets integrated into a larger application, right? We tend not to have notebooks that just kind of live forever and get developed forever. Maybe that happens sometimes, but in my experience, if a notebook lives long enough, it's because it's important enough that at some point someone's going to want to put it in production. And so we've got these interactive values that are mostly velocity oriented, and they're primarily aiming to minimize the costs of exploration and new development. We've got these non-interactive values that are mostly production oriented that are aiming to minimize the total cost of development over the long run. And so for the software that stops being used, I think it makes sense for us to optimize for these velocity-oriented values, where we want to be able to get ideas out of our head as fast as possible. And for software that's used for a long time, I think it makes sense to optimize for these production-oriented values, where we're minimizing sort of the long-term integrated cost of development. The problem is it's hard to tell which something's going to be ahead of time, right? If I'm working on a notebook, I don't necessarily know whether this is going to be a one-off throwaway sketch of something, or it's going to be something that I'm going to want to turn into a service or put a server behind or run in production, every day. So what do we do about that fact? So I think one way that we can try to kind of hedge against this problem is to try to get the best of both worlds when we can. And one of the ways that I think we can get the best of both worlds is to organize our software into layers. And so, like Shrek says, ogres have layers, onions have layers, software has layers. So I think one way that we can get a lot of the benefits of sort of both interactive and application development is to build kind of a core layer of code that's optimized for these production-oriented values that uses defaults sparingly, that doesn't depend on global state, that passes values explicitly, that's not necessarily, that's being robust in its error checking or robust in its input validation. And then it's often the case that I think we can build sort of friendly interactive layers on top of that core layer. And so again, to sort of show you my really nice diagrams, you can kind of have this core layer of abstraction that's shared across your stack. And then you can have an interactive layer that's designed to provide sort of an interactive friendly API on top of your core. And you can build your applications on top of that core, and then you can write your notebooks on top of that interactive layer as well, or you can write your REPL sessions on top of that as well. One thing that I've had a lot of success with in this regard is putting Ipython profiles in source. So most people sort of have an Ipython profile if you used Ipython a lot. It allows you to have kind of snippets of code that you want to get automatically loaded into your environment, and most people, I think, use that for kind of their own little personal snippets or whatnot. But a thing you can do is if you've got an application with a useful core library that's not necessarily designed for interactive use, you can put all of your little helper functions for getting an instance of your data portal class or whatever it is that you call it. You can put that in source control so that anyone who's working with your application can do ./my/Ipython and immediately have a nice interactive console to all the facilities that your application provides. So I think this sort of layered architecture pattern has applications at many different scales of code organization. So at the module level, at the library level, there's lots of examples of libraries that do this. So for example, H5Py, the HDF5 library, has like a high-level API that's written in pure Python, is designed for interactive use, as well as a low-level API that's essentially auto-generated Python bindings for the C API. And so depending on what you're doing, you can use the high-level API when you want it, but you can also drop into that lower-level API if you care about the performance. Trio and cryptography have this concept of hazmat modules. Those are sort of the lower-level primitives that the high-level user-facing tools are built in terms of. And then finally, a newer example that I like that's sort of very explicit about this is a library called Tsar, which is a data storage library that's kind of trying to be a replacement for HDF5. And they actually have an explicit Tsar.convenience module that exports a bunch of stuff that's designed for easy interactive use. You also can get this, I think this sort of fractally nests at different parts of your application. So another place where you can get this is classes, where if I've got some class that takes lots of complex parameters, I think often the temptation is to put lots of defaults on those things, so it's easy to construct an instance of that class dynamically. And I think often a better pattern is to make the constructor of my object just take all of the explicit values, which allows the constructor to be really simple, just assigning values or assigning attributes to self. And then you can provide these sort of smart constructors, these helper constructors as class methods, where I can say, make an instance of my complex object from a configuration file or from some other resource that's easy to construct in the REPL. And this allows us to have the simplicity of not having to deal with default handling all over the place in our application, but still have the convenience of the higher level application, or the higher level interactive use case. And I've got some other stuff about functions that I'm going to skip over here. But I want to emphasize that this is not a silver bullet. One of the costs of this is you've got more API surface to maintain. It might be more work in the short term, though often I think it's work that you were going to do anyway. So if you have that lower level core interface already, it's usually not that much more work to build the interactive layer on top of it. It's still harder to test those interactive friendly layers, but you probably weren't testing them before. And it's probably easier than it would have been before anyway. So I think it still ends up being a win in a lot of cases. So to wrap up, because I think I'm running low on time here, One thing I want to emphasize is that if you disagree with the design of a piece of code, I think it's a useful exercise to try to understand the ways that the software values of the author of that code might differ from yours. And in particular, to think about whether the way that that user or that author expects to interact with that code might differ from the way that you would expect to use it. Another thing to think about is that if you're designing code that will, maybe not immediately, but eventually be used in application, consider the implications of your decisions for things like maintainability, for testability, for modularity, for robustness. And sort of take the other side of that. If you're designing code that might be used interactively, consider the implications for things like ergonomics, for discoverability, for flexibility. If I do .tab and tab complete on the main class in my module or the top level module, do I get useful information? Can a user easily navigate this thing? Can I use the application in a reasonable way without having to construct 15 intermediate objects? Finally, I want to say that when we're faced with trade-offs between these divergent values, one useful technique can be to separate your code into layers that can cater to different modes of usage. So you can have a foundational core layer that can be built upon for applications, and you can build sort of interactive friendly layers on top of that. So we can organize modules into these core and convenience layers. We can consider adding smart constructors as class methods of our objects. We can often write helper functions to make sort of common patterns more ergonomic. And with that, I think I'm just about out of time, so thank you all for your time. And I do have a link to the slides up here. They are not up there yet, so don't go trying to look at them immediately, but those will get posted sometime later this afternoon. And I think we're the last session, so I don't know that we've got a hard deadline. So if there's any questions or comments or anything like that, I'm happy to answer. Yep.
So what's a major challenge with layered data systems is that most people are likely to build libraries on top of the most convenient layer. And so the challenge then is if you want to build something that can't use the convenient layer, then you can't import any of those libraries or any transient dependency that might include anything in the system. And so I guess how do you design, like for example with Pandas, right? If you want to make sure none of your dependencies have Pandas with like timestamp strings, right? Then you would have to do this like thorough vetting, and it's likely that most people developing libraries wouldn't have like the rigor necessarily to always use the core library. So like how do you, like are there ways you can structurally design your layered libraries to avoid these kinds of issues that are around?
Yeah, so I think one assumption there that I agree with to some extent, but also want to challenge is the belief that if I'm using Pandas, that I'm somehow like transitively infected by these convenience features that they've added. And that's true to some extent, but I think you can also restrict yourself to the way that you use, those libraries in ways that allow you to, to get kind of the robustness guarantees that you'd want to get out of them. But yeah, I mean, I don't know that I have an immediate answer for that beyond like I think testing is a good way to do this. So like the worry of depending on something that uses that provides these convenience features or provides these features that are primarily geared for interactive use is that you're going to get bitten by one of these when you didn't expect it or when you didn't want the convenient feature. And so I think the best way that I know how to do that is just sort of like good test coverage of the code that you care about, and that you're making sure that you're validating whatever inputs that you care about, or in some cases like you're willing to live with the fact that you might get like if a user gives you an unexpected input, then you might produce an unexpected output. Like I think that it's hard, especially in a language like Python, to totally defend yourself from something like that. Yep.
Thanks for your talk. That was very interesting and very appreciated. I've done a lot of work in geophysics, and we encountered those exact same use cases where somebody's going to be deploying a script on a cluster, and for the most part, though, people are using notebooks and interacting with the API. And just one of the libraries I wanted to point out that might be of use is what's called properties. And so we've used it as a way to enforce, to allow sort of a bridge between convenience as well as strict use of different parameters under the hood. So it allows coercion and strong typing and things like that.
Interesting.
So yeah, something that might be really good.
Yeah, and so just for the recording, the suggestion was there's a library called Properties is the name of it. That's for like argument validation or okay.
Coercion validation.
Okay, yeah. Yeah, we've developed a very similar library that's internal in Zipline called like zipline.utils.input validation with decorators for that sort of thing. But yeah, I suspect lots of libraries in the ecosystem have their own sort of little submodule tucked away somewhere for the decorator for like coerce strings to this or coerce file paths to whatever file format you cared about or all that sort of thing. But yeah, so another way that you can sort of at least be a little bit more rigorous about these kinds of convenience features is, if you can have kind of a principled approach to doing coercions where you've got, a standard set of decorators for coercing from thing A to thing B, then that at least gives you some degree of belief that it's not just ad hoc scattered all over your code base. Yep.
Do a describe on a data frame that has a timestamp in it. Do you find it surprising that it won't show you the min, the max, the median, all that?
Sorry, say that again?
If you have a timestamp in your Pandas data frame,
yep.
Do you find when you hit describe there and you don't even see the column there, and therefore you don't see the min, max, median, does that bother you at all? And if it did, where would you expect it to be? Is it a convenience function, or should it be in there?
So the question is about the dataframe.describe method, which I think the behavior that gives you like summary statistics for min, max, and percentiles for, and I believe it only works for numeric inputs, and it'll just silently ignore any columns that are non-numeric. I thought it actually supported datetime stuff as of a recent release, but I could be wrong about that. But yeah, it's sort of, I think Pandas more so than many libraries, and again, I don't even necessarily know that it's incorrect to be doing this, but Pandas tries very hard to not throw errors, and it will give you a result back even if it's maybe not a reasonable result or it's not the result that you expected. Yeah. So yeah, it is definitely like we've got a whole bunch of special case code in Zipline for like handling data frames of length 0, for example. There's a bunch of things that are not parametric over length 0. So there's like special case where if not len of data frame. But yeah. But yeah, so like it's another pattern that we've had in a lot of places in Zipline is we'll have a parameter with a default. Actually, usually that's like what to do in an error condition, and the options we usually have are either log, warn, or ignore. So it's either ignore is whatever the default behavior is, log will like log a warning or fire a warning without warning, and then error will actually raise an exception. So we do that for like the Quantopian APIs, where we've got like a team of people whose job it is to curate those APIs, or at least we've got me who's very pedantic about these things to do that. But it's hard to sort of extend that to every possible place in your library in a principled way. So, yeah. But yeah, I think to answer your immediate question, like it's surprising to me. It would be nice. I don't know if they're wrong to not throw an error there. It would be nice for them to like log something and say like, hey, I dropped this column. Like, you're not crazy. You had this column. It's just that it's timestamp, and I don't know what it means to describe a timestamp column, right? Somebody else have a question? Yeah. So the question is about what scale of data have I worked with when I'm working with Pandas. So pretty diverse scale, I would say, ranging down to like, a couple megabytes. And probably the largest thing that I've used Pandas for is, I don't know, like our minute pricing data set is like 60 gigs compressed and much larger than that uncompressed. I don't know that I've ever loaded all of that into a data frame at once. That's certainly, I wouldn't be able to do that on my laptop. I'd have to spin up a big AWS instance for that or something. But yeah, a lot of what my job is about is figuring out how to allow people to do financial analysis on moderately constrained resources. So like our target deployment environment for our research environment is like 8 to 10 gigs and like a single core. But we're trying to allow people to do analyses on tens or hundreds of gigabytes of data, and so it's an interesting challenge to do computation on that efficiently. Right. Yeah, so we I don't know if you call it clever. We've definitely done a bunch of tools for doing sort of streaming analysis on data frames. There's a whole sub API in Zipline called the Pipeline API that's about sort of doing these rolling window financial transformations. Yeah. Cool. Any other questions before I head out? All right. Thank you all so much.